Here's a problem where we have to calculate the speed of a rotating rod. So we have a 1 meter long, 200 gram rod. It's hinged at one end, as we can see in this figure here. And right there it's hinged. And notice that the coordinate system here, y and x are here. So my y equals 0 position is at its initial position. And it's asking what is the speed of the tip of the rod. So it rotates down by the hinge, it falls down, and it wants to know the tip of this rod here, just as it's about to hit the wall. And it gives us a hint that we should use conservation of energy. Okay, so here we have our initial condition, right? And here my y is equal to 0 here. And if I think about conservation of energy, I'm going to have U initial plus K, kinetic energy initial, is equal to U, potential energy final, plus K final. And so because I've set my initial position at y equals 0, this mg y initial term is equal to 0. So I can plus, and we have 1/2 I omega squared initial. So this term is equal to 0 because my y initial is equal to 0 because I set my coordinate system here. And now this thing hasn't moved yet, and so my omega initial is also equal to 0. So I have 0 energy, mechanical energy, right, initially, and then I'm going to have U final. So this is going to be 1/2 I omega final squared plus, and that's it. And so my U final, right, is going to be when it goes into this position down here, right, it is, it's actually, when it goes into this U position right here, I am going to have potential energy. This is going to be minus mg, and now the length of my rod, right, L, is equal to, I think we said 1 meter. So this is going to be 1/2 L because the center of mass is located at half of the length of the object. So I have here now 0 is equal to 1/2 I omega squared minus 1/2 mgl. Now my I, for a rod about the end, so it's rotating about the end instead of rotating about the center, so that means my I for this rod is going to be equal to 1/3 ml squared, so that's the length. And so this means I'm going to plug that in, and I'm going to have 1/2 times 1/6 ml squared omega squared minus 1/2 mgl. And now this L squared omega squared is really the velocity, so I'm going to have 0 is equal to 1/12. I'm sorry, this should be 1/3, so now this is going to be, let me erase that, it lets me. Yeah, so this is going to be 1/3. This is going to be 1/6. mv squared minus 1/2 mgl. And so now if I multiply through by 6, I'm going to, and I bring this to the other side, so I'm going to have a negative mv squared is equal to, I multiplied through by 6, so I'm going to get 3 ml. Oops. Now my masses are the same, so I'm going to cross them out, and I forgot a g over here, so now I have v is equal to the square root of 3g times L. And if I plug in my numbers, looking back at my slide here, my rod is 200 grams and it's 1 meter long. So if I plug in those numbers, I'm going to have the square root of 3 times 9.8 meters per second squared times 1 meter. And when I plug that in to a calculator, I'm going to get that V is equal to 5.4 meters per second. And if I look back, I can check to see if I got the right answer, and here answer is 5.4 meters per second, so we know that's correct.